Dear students, let us discuss the exponential problem that can be solved using divide and conquer approach. First of all, suppose we want to find out a raised to n where n belongs to n. So the simple way of writing or just developing the code for finding a raised to n is like this. You have to take a for loop here which starts from 1 up to 21, and then you have to multiply a 21 times. So this is the simple code that you can use to find out a raised to 21. Now here you can see that if you want to compute this a raised to 21, you will require 21 multiplications, and so that the complexity of this particular code, if we can consider that it is n. The question is, can we reduce the number of multiplication to find out a raised to n, and if it is possible, to reduce the complexity from n to log n. Discuss the solution that can give us the answer of a raised to n in log n time complexity. So for the same, we are going to use the divide and conquer method. So let us see this. If we apply the exponential algorithm to find this a raised to 20, then what are the steps that we have to follow? First, we have to create a table in which there are 4 columns. The first column is about multiplier. So here in this case the multiplier is a. Here we are going to write down the description of the steps. The third column is about exponent remaining, means after certain steps what are the remaining exponent, and the last column is about accumulated value. Now accumulated value is actually your answer. So we have to get a raised to 20t here in this last column. So we'll start the algorithm. So first, right now our multiplier is a, exponent is 20, and the answer is 1. Now the next step is based on the exponent. You can see here that exponent is 20, which is an even number. So whenever there is an even number, we have to divide the exponent by 2. So now the exponent is 10, and at the same time we have to multiply the multiplier with itself. That means now multiplier is a raised to 2. So that is the step when the exponent is even. Now you can see here again the exponent is even 10. So again we have to divide it by 2. So now the exponent is 5. After that we have to multiply the multiplier with itself. So right now the multiplier is a raised to 2. So we have to multiply it with itself. So it will be a raised to 4. And accumulated value will remain same throughout these steps. Okay. Now the next one, you can see here the exponent is odd. So when the exponent is odd, what we need to do is we have to subtract 1 from the exponent. So now the exponent is 4, and at that time we have to multiply multiplier and the accumulated value, and we have to store the result in the last column, in the accumulated value column. So now a raised to 4 into 1, that is a raised to 4. So now accumulated value is a raised to 4. Right? So using those steps we can conclude that if the exponent is even, we have to divide the exponent by 2 and multiply the multiplier with itself. And if the exponent is odd, then we have to multiply multiplier and the accumulated value and store it into the accumulated value column. Okay, now let us discuss the next step. So you can see here that 4 is an even number, so we have to divide it by 2. So now the 2 is there in the exponent, and multiplier will multiply with itself. So a raised to 4 into a raised to 4, that is a raised to 8. The next is now exponent is 2, that is again an even number. So we have to multiply the multiplier with itself. So now the multiplier is a raised to 16. Okay, now the exponent is 1, so it is an odd number. So here in this case we have to multiply this multiplier and the accumulated value and store here in the accumulated value column. So now we are getting this a raised to 20 and exponent is 0. So we can see that this is the completion of our procedure. Now we need to understand that how many multiplications are required in this particular method, because before we have seen in the standard method we require 20 multiplication, but here if you see, this is one multiplication, this is two multiplication, sorry, second multiplication, then after we have to multiply this multiplier and the accumulated value, so this is the third multiplication, this is fourth multiplication, this is fifth multiplication, and this is sixth multiplication. So here in this particular method, to find out a raised to 20, we require 6 multiplication. So we can see that we have reduced the number of multiplication if we apply the divide and conquer method to find the exponential. Now let us discuss the exponential algorithm. So whichever technique we have applied to find out a raised to 20 or suppose a raised to n, then we need to write down those steps in the form of the algorithm. So the very first step is that we have to identify that what input we require to write down the algorithm. So obviously we require multiplier and exponent. So here the multiplier is x and the exponent is n. So we are calling the function, or we are writing the function exponential with the parameters x and n. Now here initially we have to take one variable in which we can store the answer. So here xn is our variable in which we will store the answer. So initially xn is equal to 1. Now we have to check the exponent whether it is odd or even. So if the exponent is odd, then what we need to do, we have to multiply the answer and the multiplier and store the updated answer in xn, which is our answer variable, and at the same time we have to decrement the exponent by 1. After that, if n is still greater than 0, then we have to apply the next step when the exponent is even. So we have to multiply the multiplier with itself and store the or update the multiplier. So x is equal to x into x and the exponent is divided by 2. So that is the exponential algorithm, which is using the divide and conquer method to find out x raised to n. And all these things must be done while n is greater than 0. When n is equal to 0, we have to stop this procedure.